This stream is sponsored by Brilliant.
We have liftoff. Propulsion continues to be normal.
RCP chamber pressure looks good.
Doubling up. Roger roll, Atlantis.
Water towers can fly!
Tango Delta nominal.
Flight outside SC off. Putting in SC off.
Yikes. You bet. Okay. We don't need any more of these.
Good afternoon, everybody, and welcome to Cape Canaveral, Florida, where we'll be bringing you live coverage of SpaceX's Falcon 9, launching Nilesat 301 to orbit. Now, I'll be your host, Ian Atkinson, for this live stream. I'm a reporter with NASASpaceflight, but I'm also joined by a few friends, first of which is one of our resident Falcon 9 experts, Alex Physics. How you doing, Alex?
Good morning, good evening, good afternoon. I'm okay. I'm missing a little bit of AC action here, but it's okay.
Yeesh. Well, and I think Chris here can also agree. I'm missing out on some AC. How's it going down there, Chris?
Well, I'm outside, so I hope I'm not in the AC. Yeah, it's hot out here in Florida today. But the good news is all of the weather that we were waiting for is south and west of us. So we have wonderfully clear skies for the liftoff of Falcon 9 here.
Beautiful. And Chris and Julia are out in the field. And also, speaking of, Julia's here. How's it going, Julia?
Why, hello there. It is going wonderfully. I have a great view and the fish are jumping, so they must be enjoying that great weather as well.
Awesome. And yeah, beautiful weather out here. I mean, look, there's like no haze going on out there. And last but not least, we also have Michael Baylor is pulling all the levers here in the background. He'll be operating the stream today. Now, we are about 30 minutes away from liftoff today. Alex, do you want to take us through a little bit what Falcon 9 is doing today? Where is it taking this satellite to?
Sure. So today's mission is launching the Nilesat 301 satellite. It's a communication satellite, and it is launching it to a geostationary transfer orbit, which means the satellite's going to be on a transfer orbit to a geostationary orbit. And a geostationary orbit, for those that don't know, is one orbit where the orbital period is the same as the time that it takes for the Earth to rotate. So that means that the satellite in orbit is always above the same point on Earth. And so if you have, for example, an antenna on the ground, you can just point it to one part of the sky and the satellite's always there. So it's sort of like that kind of thing for communication satellite. Obviously, we have now Starlink and all of that, but you get it. And in this case, it is a transfer orbit. That means it's getting halfway there. It's not getting all the way there, but it's sort of like the perigee. It's an egg-shaped orbit, where the perigee is sort of at the same altitude as the low Earth orbit, somewhere around 200 to 300 kilometers. And then the apogee, it's usually around the same altitude as the geostationary orbit, but we can probably discuss later that there's differences here depending on the mission. So we'll probably discuss about that later, I think. And
Sure.
yeah, that is all I think about the mission. There's more stuff, but I think anyone else can probably add about that.
Yeah, I think the only thing I would add is that geostationary transfer orbit missions used to be the bread and butter of what SpaceX did. And
Yeah.
we were here for many of them, multiple times a month. And this is the first one in a long while. It's the first one this calendar year for SpaceX. That is for sure. So, a bit of a different mission from what we've been used to, but one that they have a lot of experience in. And yeah.
Very cool. And Chris, you actually took the words right out of my mouth. I was just about to say that. But yeah, first GTO mission of the year. And like Chris said, there used to be a lot of these missions. If you guys remember, if you were watching SpaceX back between, let's say, 2016 and 2019, it seemed like every month there was a new GTO satellite. But now, like Chris said, it's been about 6 months since our last one. I think the last was a Turksat 5B in last November or December or something. So it's been a while.
It was indeed Turksat 5B, yeah.
Yeah, and that's kind of showing how there's been a slump in GTO satellites, and that's because over the course of, like I said, 2016 to 2019, a lot of ComSat operators were launching their satellites then. Now all their satellites are up. There's very few that need to be launched now, but very cool to see kind of how the commercial market works. But also regarding this webcast, if you guys have any questions regarding the vehicle, the satellite, the launch pad, SpaceX, anything like that, hit us up in chat at NASASpaceflight. Make sure to tag us at NASASpaceflight because that makes your question pop up in some fancy software Michael wrote. So be sure to tag us in chat if you have any questions. We'll go through as many as we can over the course of this live stream. But right now, we're about 27 minutes into flight. Falcon 9 has entered propellant loading, which is a major step in the countdown. Right now, it is being loaded with RP1, which is a refined form of kerosene in both the first and second stages, as well as liquid oxygen in the first stage. So very cool there. And our first question here is from Martine, I believe it might be pronounced. Will Falcon 9 do an RTLS? Alex, do you want to take this one? What's this mission doing in terms of a landing? Is it returning, landing on the barge, not landing?
Well, sadly for those that are watching in Florida, it's not coming back to land. But we're going to have a landing anyways. We're going to have a landing on the drone ship, which is just read the instructions for this mission. And actually, for this mission, it's going to be the farthest away for a Falcon 9 mission that we know of, because sometimes there's probably couple of kilometers up in there, up and down. But for this mission, the landing coordinates seem to be at least 10 kilometers farther away than the previous record, which if I remember correctly, was Tycho made back in May 2016, if I remember correctly, which is a long time ago. But yeah, I think this one was 387 kilometers, if I'm not wrong with that.
687, I believe.
Yeah, 600. 600.
Wow,
Yeah,
we're really close.
I was gonna say it's coming back.
Yeah, I was like,
yeah.
There's
somehow
parking
I
lot
said
short.
300. I don't know why. I got the 87 right. So
Hey, you're 2/3 of the way there.
yeah,
Yeah, and for some context, Julia, they're it's a little farther away, but they're in the ballpark, but a little bit further away.
Right. They are a little bit further away. They are more due east than the southeast trajectory that we normally see. So the view you will be getting from our cameras is going to look a little bit more east, and that is for a reason. And just read the instructions. Bob, who's going to get the fairings, and Finn, they're actually really close to dun 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 the Bermuda Triangle.
Ooh, spooky.
Well.
Spooky, right? So hopefully we will get to see this booster come back again because this booster has some pretty good history with a couple GPS missions. We've got a Starlink or two in there, but we also have inspiration for an Axiom. So this booster has seen crew flight twice, and now this mission today.
And if that sounds a bit familiar to you, it's booster 1062-7, and it is the one that actually. Sorry, and it is the one that actually launched the Axiom mission in, as Julia said, in early April, and then set the all-time turnaround Axiom mission, and here it is again on the launch pad. So nice, good cadence that we're seeing with these boosters as well, specifically booster 1062.
Very cool. So it's a very storied booster. And do we know if the fairing halves, genuine question, do we know if the fairing halves are being reused here? I don't recall seeing any information about that.
We do not. Stephen Marr, our photographer, one of our photographers.
Oops, sounds like we're losing Chris a little bit here.
There's nothing on the payload fairing. It's like the.
Sounds like we're.
No.
Whoops. Sounds like we're losing Chris a little bit here. Again, Chris and Julia are out in the field right now. They're the ones bringing you this live coverage. And they've been saying coverage is a little spotty out there today, so we'll bear with them as they deal with these signal issues. But so they're out in the field. They're not sitting here in the studio with us where we have nice connect into the wall internet. They have to deal with that weird wireless stuff, that 5G. But yeah, Chris is in robot mode. That's right. But another question here from Marwin asking which coordinate or which place will the satellite end up? So it'll be ending up 7 degrees west. And I believe that's 7 degrees west of the, what's it called? Prime Meridian, I think that's what it's called. But yeah, it will be servicing over Egypt and the Middle East. So this satellite, Nilesat 301, is being operated by a company called, you guessed it, Nilesat. Now, the satellite is bringing television, radio, and internet across Egypt and the Middle East. It's replacing its predecessor, Nilesat 201, which is currently in operation. So it'll be bringing a lot of data coverage over Egypt, other parts of Africa, as well as the Middle East. And, sounds like we had Chris breaking through a little bit there. And we have a question here from Dino asking, is there a reason why they're using a booster so soon after a launch? Alex, how quick has this launch been since the last launch? Is this a really quick turnaround for this booster? Do you know?
I don't think I understand the question. So is there a reason they are using a booster again so soon after launch? So do they mean fast reuse?
I think they're discussing, like how it's been really quick reuse for this booster.
Okay. Hold on. Actually, for this mission, it wasn't that quick, if I remember correctly. The previous turnaround was the actual quickest turnaround. Like, so this booster, which is B1062-7, the previous mission was launched 21 days after the previous one, which was Axiom 1. So it was from Axiom 1 to Starlink 416. That was 21 days. And from that one to this one, it's actually more than a month. So it's not that short. There's been other boosters. Even this same booster has done even shorter turnaround times. So yeah, but I'm not sure how to respond to that question. Only that it's not really that unique today, in that sense.
Gotcha. Before we hop into the next question, let's actually go through some super chats. So we've had some build up over the past few minutes. Now let's see. Oh boy. First question from Musical Wolves here. Does Tiles Alenia Space usually have their sats launched on a Soyuz, but got moved to SpaceX's Broomstick? Oh boy. Yeah, so Thales Alenia, I don't know how to pronounce that. That's French. Thales Alenia?
It's Italian or something. I think they are an Italian.
Oh, it's Italian.
French company or something. I don't know. I do know that they have some places in Italy, but
I bet I'll have some Europeans in chat correcting me. But so these, but yeah, I'll say that company. They do launch a lot of satellites on Soyuz and Falcon 9. Oh, and actually, right as I'm talking, the T-minus 20-minute vent has started up. So that is where they are outgassing and getting rid of any excess liquid oxygen in the transporter, just to make it a little bit safer for liftoff. Now, when you're launching a rocket that has a lot of fire on the bottom, you don't want to damage your launch pad. So to not damage your launch pad, you want to get all the flammable stuff out of your launch pad. So that's why they're venting any excess liquid oxygen here. And that's also a great sign that the countdown is going nominally. We are proceeding towards launch in just under 20 minutes. But back to the question, Musical Wolves, yeah, they do launch a lot on Soyuz and Falcon 9. Now, in the future, I'm not really sure how often they'll be launching on Soyuz, given the geopolitical situation in Eastern Europe right now. But it seems they do get on a lot of different rockets. But thank you for the super chat. And James, actually, Alex might be a good one to ask for this. Why did they switch from booster 1049 to 1062 for this mission? Because I do remember they were going to expend booster 1049 on here. Was that correct?
Yes, and I'm truly not aware of why the reason, but it seems to have been about a month ago where they did the switch. So I'm not fully sure about that. I do know that B1049, it's still being expended, but the mission it's going to be expanded on, it's going to be in November. So, and it's actually not public yet. I'm not the one to actually talk about that. So, I let the appropriate people to talk about that. And once it happens, I'll say, hey, this is a mission, But yeah, around November is this mission. It's not really that exciting. It's just a concept, but I'm not going to talk about that. Yeah.
Gotcha. And actually, Mark here in chat is correcting me and saying that it's pronounced Thales Alenia. Thales Alenia. Gotcha. Thank you, Mark. Yeah. That's going to be very helpful for the future. Whoops, and there we go. But from Randall here, late to the party, asking how many times has this first stage been used? This is the 7th flight of this first stage, right, Alex?
Yep, it has launched 2 crew missions, which were Inspiration 4 and Axiom 1. And it also launched 2 GPS missions at the first 2 flights of this booster were GPS missions, GPS 3, SVO4 and SVO5. And it also launched 2 Starlink missions, Starlink Group 4-5 and Starlink Group 4-16, which was the last mission of this booster. So yeah, 7.
Very
This is
cool.
the 7th launch.
Pretty storied booster, but again, it's still not not that many flights compared to, what was it, 1051 that has the most. Yeesh.
Yeah. 3 boosters actually, 1051, 1058, and 1060. Actually, 1060 is gonna be launching the next Starlink mission, I think, in about a week or so.
Wow. So punching a lot of reuse records here. Very cool.
Yep.
But thank you very much for the super chat, Randall. And from James here, interesting question that I'm not sure if I know the answer to. Will there be a highlight video from the SLS rollout? And see, I would ask Chris, but Chris is having audio issues right now. If I had to guess, I'd say probably. Oh, and there he is again. Hey, Chris, or Julia, one of you might be the best to answer.
Well, I know that we did take some video from that. Is it enough for a highlight video? I'm not sure, but I can see if we can put something, at least a little something out there. Some of that video does make an appearance in the latest Cape flyover video, so that's kind of fun. And fun fact, the weather we are having today is about as clear as the flight we took on Sunday, so you guys should get some great views today.
Yeah, looks like there's almost no haze out there right now, which seems to be pretty rare for Florida weather, which is going to be a beautiful liftoff footage right here today. But thank you, James. And yeah, very interesting question. Maybe we'll have to make a video. But again, we do have a video, I believe, of a whole bunch of footage from the Artemis 1, or the first Artemis 1 rollout. And from Jurwa here, saying, I'm going to have to keep donating till we get NSF-SAT-1 into orbit. There ought to be quite a few more. I mean, I'll absolutely take it. Put a give DOS a camera. Ooh, I actually like that idea. Put a robotic camera on a satellite and just have footage of Earth.
Wait, what are you signing me up for?
A sudden DOS has appeared. Hi DOS. Don't worry about it.
I heard camera and I heard robot in space, so I was all about that. So let me know where I need to ship something.
Someone's asking if we should put NSF-SAT-1 into orbit, and I'm saying we got to put a camera on that. But very cool. That'd be very cool to see. Thanks, Jerwa. And from Tim saying, 20-minute vent. How active are payloads before/during launch? Guidance, thermal, etc. Fully active or in sleep mode? That's actually a really good question.
Good question.
Yeah, Chris, do you want to take that?
Yeah, the annoying part of the answer is it kind of depends on the satellite and what's going on. When we talk about satellites specifically, right? Like Nilesat 301, they are usually in some kind of not fully powered up, but they are powered. They're not fully hibernating. They usually do have some degree of awareness of what is going on. They transfer to internal power in the final 10 minutes of the countdown. And then, and that's usually why one of the first things you have to do once you get to orbit is immediately deploy the solar panels and everything to get the vehicle power positive. But yeah, they usually have some form they're usually awake to some degree, but not fully awake, if that makes sense. But satellites are not actually trying to measure anything as they're getting to space. Unlike a communication satellite like today really isn't trying to do its job until it's actually in orbit and unfurled and going through its commissioning phase and everything, which will take GTO missions. It can take anywhere from a couple of weeks to a couple of months to fully check out a satellite once it gets into orbit.
Very cool. And yeah, that's actually good to know. And from Musical Wolves here with the $2 super chat saying, Starlink voice over IP signal fund for Chris. Thank you very much. We really appreciate that. That'd be fun. And Rough Rider Show saying, thanks for rolling out, Chris and Julia. Is this the furthest downrange drone ship landing on record? Alex was saying before, this is the furthest Falcon 9 drone ship landing, but not the furthest ever. I think STP-2 was like
1,000
1,070.
kilometers downrange.
Yeah, that was intense. And of course, as we know, the booster did not survive because of that intense heat, the heat from reentry. But this drone ship landing is the most for Falcon 9, and it's 687 kilometers downrange. So pretty far downrange, but not as far as STP-2's center core. But good
And
question.
to sort of give a little bit of and to sort of get a little bit of context for that, the normal location of the drone ships are like approximately 630 kilometers downrange. So 330 to 630 to 680. Not that big of a difference, but enough to break the record.
Very cool. And from Moldy Space Industries with hashtag Alex Fan Club, and I am plainly insulted you did not do hashtag Ian Fan Club or Chris and
I was
Julia
about to
Fan
say
Club
the
as well.
same. I was about to say the same, and I'm the one that the super chat was about me, but I'm gonna say I'm also Ian Fan Club and Thomas Fan
Aw.
Club. Like, everyone here, like this team is just amazing. I'm super proud with everyone here. Yeah,
I can second that. This is a great team to be a part of. So hashtag everyone fan club, but thank you very much, Moldy Space Industries. And from Brian here, $5 super chat with no message, but we still equally appreciate it. Thank you very much, Brian. And Jim, happy halfway to NSF Live Day. It is Wednesday. See, I'm losing track of the days here. But yep, so it is halfway to NSF Live next Sunday. So make sure you tune in for that. And from Stefan here with €5 saying a big thank you from the Netherlands. Well, thank you for tuning in, Stefan, and thank you for the support. And JD Brown here asking, what does SpaceX do if a fairing suddenly goes missing and ends up never recovered by them? That's an interesting question. I mean, I'd assume they would just, go about it as if they just expended the fairings. Do you guys think so?
I think so too, because if they never found it, a safe assumption is it's probably broken up and going to sink. I'd imagine they probably have some sort of a locationing device on them, just because they do have to, they have their own kind of landing zone. So just like a drone ship and a rocket, they've got a system, shall we say. So I think the safe assumption is if they can't find it, it is probably sunk. If they can find it, though, they bring back the larger pieces just because that's being kind to the ocean.
Very cool. And yeah, we want to have as minimal pollution as possible. Now, one actual neat thing to notice here is Falcon 9 is now doing has a lot of condensation on the side. You see that little white smoke or white, gas coming off towards the bottom of the vehicle? That is condensation because not only is Florida super humid, but the liquid oxygen inside the tanks is so cold that it'll actually freeze the water from the air onto the side of the launch vehicle. Now, if you've ever had a nice cold glass of water or iced tea on a summer day, and you notice the side of your water glass get wet, that's pretty much what's happening here. But the thing inside the glass is a lot colder, so that water actually freezes, which is very cool to see. But again, we are just under 10 minutes away from launch. But before we get back into any other questions, I would like to thank Brilliant for sponsoring this live stream. Now, Brilliant is an interactive learning platform online that lets you learn at your own pace. Interactive learning has been proven to be the best way to learn. Now, Brilliant has tons of courses available in science, physics, math, and more, and each lesson has quick questions and hands-on examples. And if you get a question wrong, they even give you a very detailed explanation on how you can find the answer. So as Michael's showing up here on the screen, one lesson I've been working on personally is structures. Now, structures are essential at rocketry, and I mean, just look at the camera on the right. Look how many structures and beams and everything you can see there. It's absolutely essential in rocketry. Now, there's one example in the lesson has you trying to build beams on a bridge. Now, it turns out, actually, the best way to build beams on a bridge is to make an X of beams. And you can see there, having cross beams provides a lot of support and a lot of structure. So very cool to see interactive learning with Brilliant. Now, with Brilliant, you could start for free, and the first 200 users to use our code NASASpaceflight or to go to brilliant.org/NASASpaceflight can get 20% off an annual premium subscription. So thanks to Brilliant for sponsoring this live stream.
And you know what's really cool about that, Ian, when you said structures and crossbeams?
Yeah?
We've got an example of it on screen right now. What are those 4 towers around the rockets? Have crossbeams in between the 4 legs on those towers to keep the towers sturdy and rigid. And at some of those levels where they have to add the crossbeam sections and everything, they mount weather stations to them because it's a neat little bonus once you have to beef the towers like that to make sure that they're still standing tall. So yes, structures. About lightning protection too. Our favorite towers, yes.
Very cool. The famous 4 towers.
Which we don't need today, and we're very grateful for that.
Yeah, the 4 towers that you hope you'll never ever need to use, but are there in case you need to use them. And if anyone's wondering why you need
They're
lightning
actually the
protection,
towers there that we really want to use, yeah.
yeah. But if anyone wants to know why you need lightning protection towers, look up Apollo 12. Just look up Apollo 12 and trust me, you need lightning protection towers.
Yes, indeed. Take SEC to Aux. Yes, we hope we only hear that
Yes.
once in spaceflight history. But yes, questions before we hit liftoff, yes.
Absolutely. Let's get a few more questions here. We're just over 7 minutes away from liftoff. We'll do a few more questions and we'll guide you through what exactly we're going to be seeing during liftoff today. And ECR off 25 starting off, we just had a bit of a tower discussion, but they're saying, what is that stubby white tower in the lower right? So I assume they're looking at the little half sphere looking thing down there. That is the liquid oxygen sphere. Now, as the name suggests, that is where liquid oxygen is stored on the ground prior to launch. Now, that sphere is actually kind of interesting. It has a very storied history. That same sphere right there was first installed at LC-34, Launch Complex 34, which is just a few miles down the road from here. Now, LC-34, for those of you who may not know, was one of the first launch pads in the Apollo program. That was where the very tragic Apollo 1 fire occurred, but where the very successful Apollo 7 mission launched from, as well as several other Saturn 1 and Saturn 1B launches. So that is a very historic liquid oxygen sphere right there. Nice little side tangent I'd like to share.
And to be specific, it's the storage sphere that fueled all of the test Saturn ones that certified that rocket to carry people and do everything that it did for the Apollo program.
Absolutely. And the Saturn rocket was one of the largest steps in rocketry history. So much technology that we use today, not even just on rockets, but also in your cell phones and your digital watches, come because of technology the Saturn rockets developed. But that's a story for another day. I could go on tangents for that for hours. And let's see, another question here. Nicholas, this actually might be a good question for Alex. Any updates on the CRS-25 issue? So we heard something about there was some propellant leak or something happened. What exactly happened there? Have we heard anything?
Well, we had a press release from NASA saying that they had found, readings of propellant, monomethyl hydrazine in this case, that were elevated than normal. Like they just found some readings like that on one of the compartments in one of the Draco thrusters. So they're gonna take a look at that. They're gonna be, seeing what's the source of that elevated reading. It could be just the sensors. It could be that there's just a trace amount of it from, just pure handling of the spacecraft while doing the propellant loading, or it could be a leak. Like, it could be anything, right? Right now, that's the only thing that we know. So it seems like it might not be that major of an issue because they have targeted the launch now for June 28th, so that it's only being delayed by 3 weeks. So it's probably not that big of a deal, but still, it's hydrazine, right? And when there's traces, even traces amount, you're kind of like, where's this coming from, right? So you want to take a look at that, be sure that it doesn't repeat, that there's nothing major going on there, and cross the T's, dot the I's, make sure that everything is okay.
Absolutely. The next question here, let's see, from Keith here asking, will the second stage re-enter or go into a graveyard orbit? Now, let's see, I believe the second stage kind of does neither. So it doesn't do a re-entry burn or a deorbit burn, but it also doesn't go to a graveyard orbit. They kind of leave it in orbit, and over the course of the next few weeks, next few months, because it has a very low perigee, or which is the lowest point in the orbit, it'll begin to naturally decay and probably burn up by the end of the summer, if I had to guess. But yeah, the second stage won't be intentionally deorbited, but it will not be put into a permanent graveyard orbit. Very cool question here. And from Wolvie here, asking a little off-topic question, but can the RL-10 handle significantly higher chamber pressure than it operates at? That's a pretty quick question to answer, and probably no. Significantly higher? Definitely not. Rockets and rocket engines and rocket components are designed to handle stresses that are not much higher than what they'd see in flight. That is to save mass, to save money, and to save performance on the rocket, because as we know, every kilogram of unnecessary weight on a rocket reduces your payload capacity. So you don't want to build your engines to be super strong when you don't need them to be super strong. So they just build them to what they need. So it can't really operate at a much higher chamber pressure. And that actually goes for a lot of rocket engines, whether it be the Merlin or the Raptor. They can't, say, double the internal chamber pressure without doing major engine modifications. But good question there. And Joshua here asking, what happens if SpaceX has to abort during launch? Well, that's pretty simple. If you just have a payload on board, you don't. You don't abort. If something happens during launch, it's basically hope that your rocket knows what to do and can take care of itself, if you know what I mean. But anyway, we're coming up on about T-minus 2 minutes here. So, Alex, how about we take people through what we're going to see ahead of launch here? So at T-minus
Sure.
1 minute, what are we going to be seeing?
Well, in about 1 minute, we're going to see... Well, we're actually not going to see anything because it's not a visual thing, but we're going to see... Actually, right now, we should be seeing some puffs that it's gas closeouts. The rocket is now fully loaded. They need to drain and properly secure the lines on the Stromback so that there's no any sort of fires in the pad. And there we see the venting from the Stromback. In about 30 seconds, the rocket will pick up the automated countdown. Instead of the ground systems, it's going to be the rocket computers that are going to take control of the countdown. And then about T-minus 3 seconds, the engines will ignite, ramp up to full power, and lift off. And then after that, throttle down, about 1 minute into flight, max Q, supersonic. And about 2.5 minutes, it's when it's the MECO and the stage separation. So that's going to be when the action comes in with the MVAC ignition, the fairing separation. We're going to see a lot of stuff right there. Yeah.
Very cool.
And
we're up at...
we are already on startup. Yeah, I think, they have confirmed startup right now.
Yep. So just over 30 seconds away, vehicle's pressurizing for flight. They're finishing up all venting. You'll see the venting both on the Strongback and the vehicle close out in just a few seconds here. They're basically getting it ready for flight. And then I believe T-minus 13 seconds, Alex, that's when they have the last chance to abort. Is that correct?
T-minus 10 seconds. They can do a manual abort all the way to the T-minus 10 second mark. So
awesome.
We're approaching that now. I'll hand it to you.
And T-minus 10 seconds will be coming up again, as Alex said, engine ignition at T-minus 3 seconds, followed by liftoff. So let's sit back, relax, and enjoy a rocket launch. We've had ignition and liftoff. Falcon 9's carrying Nilesat 301 onto a geostationary transfer orbit, and we're seeing beautiful coverage of this liftoff from Pad 40. Now we'll be hearing the sound here in a few seconds as we're a few miles away. Here it comes. Beautiful and successful liftoff so far of Falcon 9 from Pad 40 at Cape Canaveral Space Force Station. Now we just passed through max Q, which is the moment of maximum aerodynamic pressure, and it looks like all is well on the vehicle. Now the next milestone will be main engine cutoff, coming in just over 1 minute, where the 9 first stage engines will shut down.
I'm looking forward now to the impact chill. Sometimes we kind of can see the venting from the engine chill on the side of the rocket. They have a vent on the interstage.
Very cool.
There we go. You can see it right next to the grid fin. You can see some puffies of like cloudy thing, vapor thing. That's the impact chill. Yeah, a lot of people miss that, but it's just that. Really cool.
And look at that beautiful onboard shot. You can see those anvil clouds from over Florida right now. Those were actually one of the biggest concerns over launch readiness. They were worried about cloud rules, and you can see some of those beautiful clouds they were talking about right there. But a gorgeous onboard view right here from Falcon 9.
Thankfully, they avoided them.
Yeah, absolutely. Now we're coming up on main engine cutoff, and one of the neat things here, you can see the plume has gotten a lot larger because they're getting out of the atmosphere, and there's no air pressure to hold the plume in, so very cool to see. And looks like we've had main engine cutoff. Next event will be stage separation, followed by second stage engine ignition.
And there we have it.
Beautiful.
Back ignition.
Awesome, and all looks well now. So we'll be looking at about a 6-minute burn here on the second stage engine, and this will insert the satellite into a parking orbit, which is a very low orbit around the Earth. It's very temporary, and from which they will then reignite the second stage engine to boost it to a proper geostationary transfer orbit. Now this parking orbit, if I recall correctly, Alex, the parking orbits are usually around 180 to 200 kilometers in altitude. Is that correct?
Yeah, sort of like that. It kind of depends on the mission to GTO, but yeah, sort of like that.
Awesome. And you actually see there just under, and we lost that view, but you could see Cape Canaveral in that engine shot.
They are in separation confirmed.
Beautiful. So now Nilesat 301 is now exposed to the vacuum of space for the first time. And you see that fairing falling back. You can actually see Cape Canaveral right behind that view right there. So it's cool to see where the rocket launched from. And we also have some onboard views of the first stage here. You can see the grid fins have deployed. Those will be guiding the first stage back down to the landing zone as it attempts landing in about 5 minutes.
And you know what's awesome about that view from the second stage, Ian, is you can see all of the Florida afternoon thunderstorms we were worried about that just stayed away from the Cape. So that was good. Thank them all for going elsewhere today.
Yeah. And absolutely, you're right. Florida has gets really stormy in the afternoon usually. Is that right?
This is the first day in over a week where it has not been pouring down rain at 5 p.m. Yes.
Wow. Well said.
At least where I've been, it's pouring down rain somewhere for someone. But
wow, that's crazy to hear. But I mean, it's in a very tropical place, so it makes sense. And 4.5 minutes into flight here, second stage is performing nominally, and the first stage you can see is coasting over the Atlantic Ocean towards the drone ship. Just read the instructions.
We're about a minute or so till entry burn. That's when the Falcon 9 booster is gonna ignite one engine first, then two engines. Then they'll fire for about 20 to 30 seconds. And then the other two are going to shut down, and then the center engine will shut down. That is done for basically the propellant on the tanks to be able to settle when doing the ignition.
Very cool. And was that an interstage shot there?
I think
Getting
so, yeah.
blown out by the sun. But again, you can see the first stage is still reorienting itself, like Alex said, for the entry burn in about 1 minute.
You can actually see the difference between 1, 3, and then again 1 when it does the burn. You'll see first the center engine, the burn is going to be sort of like circular, and then when the other two engines ignite, the plumes interact with each other, and you can see sort of like a line in the exhaust. So you're going to see that, and it's super amazing. When you actually realize that, it's super amazing. Like, hey, that's 1, and then that's 3.
And one actually cool fact is, after the first stage cuts off, we actually missed it about 30 seconds ago. It's actually going in space, so it's above the Kármán line, about 120 kilometers up. So the first stage actually touches space for a little bit before it comes down, but right now you can see it's beginning to orient itself for the entry burn as it re-enters the atmosphere.
And watch that velocity, 8,300 kilometers per hour right now, and watch how
There
it
you see
falls when.
one
There we go. So watch
and
what
three.
it does when the entry burn ends. That's the cool part of physics.
Yep. You'll see a very nice demonstration of what atmospheric reentry is. But all looks good on the entry burn there, and look at the velocity just rapidly slowing down there. The
Now
first stage
one
is
engine and shut down.
And now look at the velocity. It's going
Yep.
back up. But as that altitude drops below 40 kilometers now, watch, it will reach a point where the air thickness, we're at that point right now, is now pushing at that same, and now the velocity is starting to go down. So now the
It's going
air
down.
resistance is starting to slow it down now.
Yep. The first stage is slamming into the atmosphere. Now watch those grid fins. You might actually see some reentry heating if we don't lose signal, which it looks like we just did.
Oh,
Ian, what have we told you about talking about Signal Club?
I'm sorry. Put Starlink on the booster. But it looks like we're still getting telemetry from the first stage, and it is rapidly slowing down as it's slamming into the atmosphere. Now, right now, it is still going far over the speed of sound, but over the next few seconds, it'll then slow down to below the speed of sound. Then the first stage, a single engine, will ignite. Alex, you want to guide us through what this landing burn looks like? How many engines they're using?
well, for this one, they're going to be using the center engine, and it's going to be about 29 seconds, if I remember correctly, from the timeline that SpaceX releases. If not, I think it is. Perhaps I'm off by 5 seconds because I don't remember exactly the date, the times, but yeah.
Very cool.
20
Well,
or 29.
I think the hard thing with that too is it's somewhat mission dependent too, right? Based on the
Yeah.
day of velocities that the boosters are actually going. So those burn times can actually deviate by a few seconds from what's predicted, but that doesn't mean there's a problem. Yeah.
Yep. Oh, and we got some live views here from the drone ship. Let's see if we can get a nice clean shot of the first stage.
Well,
Looks like we don't have video.
There we go.
There it is.
Hang on.
it was very
Just-
weird.
And poof, there it is.
Yep, the first stage just spawned in. And it looks like we've had a successful second engine cutoff. So now the second stage is coasting since it's in a parking orbit. In about 20 minutes from now, they're going to have second stage reignition. But it looks like we've had a very nominal launch there. I'm going to run through some of our super chats here, and then we will call it a day. But first off, from Moldy Space Industries. Oh, and before I say that, some beautiful pad shots right there. I don't know about you guys, but I always love seeing a launch pad after launch. Just the strong back, thrown back, all of that infrastructure, like we talked about before, all of those structures on display right there. So beautiful to see all that machinery that worked perfectly today. But Moldy Space Industry correcting their first comment saying hashtag NSF fan club, but also shout out to fellow physics gang Alex. So they're saying hello, Alex.
Moldy.
And Musical Wolves, what are the 4 blinky brooms? Well, those are the 4 lightning protection towers that we talked about before. But thank you very much for always asking that question. The one thing we can rely on, Musical Wolves asking, what are those 4 towers? Oh, and Skip here saying hashtag the whole NSF live team fan club. We appreciate that. Thank you very much.
Aw, I feel loved.
Absolutely love for the whole team. But also my moment to shine from Nikon's hashtag Ian fan club. Thank you very much. I appreciate that. And from Wolfram here to the Gator Defense Gear Fund for those out in the field. The Gators, did you guys see any Gators out there today, Chris or Julia? Any alligators?
Not today, but to be fair, it's a little early for them. They're more active around dawn and dusk. They tend to see the view of the day going underwater, so I haven't seen one today.
Cool. Sounds like Chris went a little robot there, but it sounds like he said he has not seen any today. But thank you, Wolfram, for the super chat and the support. And from Thomas here, interesting question. Do you think Falcon 9 will ever switch to Methylox in the future to reduce turnaround time, or will they always stick with what they're using now? Alex, do you think Falcon 9 will change propellants? Is it easy to change propellants, do you think?
It is not easy to change propellants. I can say that. It will need a lot of redesign. Yeah. that's why Starship is a thing, you know?
Yep,
So, yeah.
absolutely. Yeah, it's not easy at all to change propellants. I think there's only one rocket engine that I really know of. I'm sure there are others, but there's only one that I know of that could easily switch propellants. That was the LR-87, the Titan rocket engine. But
Yeah, but that's the engine,
yeah,
not
that's
the
the
rocket
engine.
itself.
There's
Yeah,
a lot of work that goes into changing the propellant. It's not a quick, easy. Let's change to hydrogen. Let's change to methane. It's complicated, but interesting question, Thomas. We appreciate it. And Randall Smith with the new membership. Thank you very much for the support, Randall. And for those who are unaware, our membership program is one of the best ways to support us. These live streams are not cheap to make. The equipment is not cheap to obtain. So we really, really appreciate support through not only super chats, but also through memberships. And Randall here is our newest member. So thank you very much for the support, Randall. And last but not least, from Tim C here, saying, ditto Musical Wolves voiceover IP fund for Chris G. Looks like we're getting a nice little Starlink dish fund here. So thank you very much for the support, everybody. But on that note, it looks like that'll bring us to the end of our live stream here. Thank you, everyone, for tuning in. And thank you especially to our members, everyone who has given us super chats today. We really appreciate that because that helps us bring you more streams just like this. And before we wrap up here, a nice, beautiful look back at Slick 40 after a beautiful liftoff today. There was very little haze, a very nice looking rocket. But again, thank you everyone for watching, and thank you, Alex, for tuning in and being a nice co-host here. So thanks, Alex.
my pleasure to be here. Yeah, it was great.
Absolutely. And Chris as well, bringing us these live views from the field. Thank you very much, Chris.
You are welcome. I hope I'm not a robot.
A little robot, but not that bad right there. But all good. And as well as Julia, thank you very much as well for some photographs and some nice chatting here that we had.
And happy to be here. Happy to have been with all of you today.
It was a beautiful liftoff, as well as DOS we heard tune in a little bit there. So thanks for being here as well, DOS. But that brings us to the end of our live stream here. So once again, thanks everyone for watching. Thanks for your questions, your super chats, memberships. They all mean a lot to us. We had a beautiful liftoff of Falcon 9 here carrying Nilesat 301 to orbit. Now, I've been your host for today. I'm Ian Atkinson. Thanks all for watching, and we'll see you next time.
We have liftoff. Propulsion continues to be nominal.
Chamber pressure looks good. Doubling up. Roger roll, Atlantic.
Water towers can fly!
Tango Delta nominal.
Flight is outside SCE off. Say again, SCE off.
Yikes. You bet. Concur. We don't need any more of these.